Welcome to this video on the probability of at least one. After watching this video, you will be able to state the probability of at least one and calculate the probability of at least one in the context of a problem. Please note that this video assumes knowledge of basic probability, the complement rule, and the multiplication rule. If you have not already done so, please watch my videos entitled Basic Probability, the Complement Rule, and the Multiplication Rule for Independent Events before continuing to watch this video. What does at least mean? If you have to be at least 18 years old to vote, what ages of people can legally vote? Well, you can be 18 years old or you could be older than 18. So at least 18 means that your age has to be greater than or equal to 18. Calculating the probability of at least one. Let's say you flip a coin 4 times. Use the probability distribution shown to calculate the probability of the coin landing on heads at least one time during the 4 coin flips. Which of the events in the table represents at least one head? Well, you could flip it exactly once or more than one time. So you could get 2 heads, 3 heads, or 4 heads. So all of these are contained in at least one or at least once. So one approach to calculating the probability that at least one head appears during those 4 coin flips would be to simply add the probabilities of these 4 events. Doing that, we find out that the sum of the probabilities is 15 over 16. This is a valid approach, but as you can see, it's a bit time consuming. And if we had more outcomes, for example, if we flip the coin 10 times, then it would be even more cumbersome and time consuming. Can you think of a shortcut? Pause the video, write down your answer, and then unpause it to see if your answer agrees with the video. Instead of adding all the probabilities together that represent at least one, we could apply the complement rule. Notice in the table the only event that isn't part of at least one is the event 0 heads. We will call the event 0 heads none. Recall that the complement rule says that the probability of the complement of an event happening is equal to 1 minus the probability of the event happening. Since the events at least one and none are complements, we find that the probability of at least one is equal to 1 or 100% minus the probability of none. So the probability of at least one is literally just an application of the complement rule. The probability of at least one is equal to 1 minus the probability of none. How is the probability of getting 0 heads in 4 coin flips calculated in this table? As you can see from this chart, the probability of getting 0 heads in 4 flips of the coin was 1 over 16. But how is this calculated? Where did this value come from? Remember that coin flips are independent. Every time you flip a coin, you have a 1/2 or 50% chance of getting heads, which means, based on the complement rule, you also have a 1/2 or 50% chance of getting tails. So, since you are flipping the coin 4 times, you're going to multiply the probability of not getting heads, i.e. getting tails, by itself 4 times. This is an application of the multiplication rule for independent events. So again, we're flipping the coin 4 times, so we have 1, 2, 3, 4 probabilities that we are multiplying together, and they're all the same because we are treating these events as independent. So we have 1/2 times 1/2 times 1/2 times 1/2. That gives us 1/16, which is about 6.25%. Notice this 1/16 here matches the value in the table. It's important to note that in subsequent at least one probability questions, you will be required to calculate the probability of none first before using the at least one equation. Let's get started on our first example. About 11% of the population is estimated to be left-handed. If you randomly select 3 individuals, what is the probability that at least one of these people is left-handed? So we're going to be using the equation, the probability of at least one is equal to the probability of none. But before we can apply this equation, we have to evaluate or figure out what the probability of none is. So how do we know that it's 3 people? Well, We know that we're going to be looking at 3 people because it says that in the problem statement. So the probability that none of these 3 people are left-handed is the probability that the first person is not left-handed times the probability that the second person is not left-handed times the probability that the third person is also not left-handed. But what's the probability that somebody isn't left-handed? Well, we know the probability that someone is left-handed is 11%, so we can apply the complement rule and find out that if about 11% of the population is left-handed, that means about 89% of the population is right-handed. So putting this value of 0.89 into that equation, we have 0.89 times 0.89 times 0.89. That's about 70.5%. Now, be careful because at this point, a lot of students are like, well, I've been working on this for a while, I must be done. But remember, at this point, you have not found the probability of at least one. You've only found the probability of none. So we need to find the complement of this probability, and we do that by subtracting it from 1, and we find out that the probability of at least one of those 3 people being left-handed is about 29.5%. So let's break down what we just did into some steps that we can follow every time we have an at least one problem. So the first thing I usually do is I write down this equation on my paper, because if I see the phrase at least one, I know that I have to use this equation. So in order to employ this equation, the first thing I have to find or calculate is the probability of none. So I use the complement rule to find the probability of the event not occurring. In the last problem, we said that 1 minus 0.11, which is the probability of someone being left-handed, is 0.89, which is the probability of someone being right-handed. Then we multiply this probability by itself as many times as there were trials. In the previous example, we were picking 3 people, so we had 3 trials. That meant that we multiplied 0.89 by itself 3 times. Once we calculated the probability of none, we couldn't stop there. We had to continue to find the probability of at least one. And again, we did that by putting the probability of none into the equation. So 1 minus 0.295 is 0.705, or about 70.5%. Example 2, COVID-19 testing. A test for the absence of the COVID-19 antibodies is accurate 99.7% of the time. The other 0.3% of the time, the test results in a false positive. Suppose the test is given to 4 randomly selected people who do not have COVID-19. What is the probability of a false positive for at least one of the 4 people being tested? So let's use these new steps that we have to work through this problem. The first thing I do is I write down the probability for at least one. In this case, you can see that I've put it into the context of the problem. So the probability of at least one false positive is equal to 1 minus the probability that none of the tests were false positives. So I have to start with calculating the probability of none. And to do this, I have to figure out which probability, 99.7 or 0.3, is the probability of the event not occurring. So if the test is accurate, if it's not a false positive, right, that happens, it says 99.7% of the time. So in this problem, this is the probability that represents not a false positive. Then we take this probability and we multiply it by itself as many times as there were trials. So you can see here we're looking at 4 people. So we multiply it by itself 1, 2, 3, 4 times. And that gives us about 0.988. Now, as you can see, as the number of trials increases, right now we're only multiplying this number by itself 4 times. But if we were doing this 8 or 9 times, it becomes somewhat cumbersome to type into a calculator. So instead of expressing it as a multiplication problem, a mathematical shortcut is to raise the number 0.997 to the 4th power. And this is equivalent, 0.997 to the 4th power is equivalent to multiplying by itself 4 times. So we will be using this shortcut in subsequent problems. So let's finish this problem. Now we have the probability that none of the trials were false positives. So we can use that to find the probability that at least one of the trials was a false positive. So we have 1 minus 0.988, and that gives us about 1.2%. Example 3, Barks Animal Shelter Adoption. Barks Animal Shelter works hard to get animals in Baltimore City off the street and into good homes where they will be cared for in a safe and loving environment. Suppose the probability of a cat or dog being adopted within the first 3 months of its stay in the shelter is 0.40. What is the probability that at least one of the 10 animals that were brought into the shelter today will be adopted out in the next 3 months? So again, first thing we do is write down that probability of at least one. Then we have to start by calculating the probability that none of these 10 animals will be adopted out. Use the complement rule to find the probability of the event not occurring. So we know the probability that an animal will be adopted is 0.4, so 1 minus 0.4 is 0.6. Then we multiply the probability by itself as many times as there were trials. How many trials were there? Well, there were 10 trials because we're talking about 10 animals and we're treating them as independent. So this time we're going to use that mathematical shortcut. So instead of multiplying 0.6 by itself 10 times, we're going to raise 0.6 to the 10th power. So doing that, we find that the probability that none of these 10 animals gets adopted out in the next 3 months is about 0.006. Now we can use the probability of none to calculate the probability of at least one. So we have 1 minus 0.006, so there's a 99.4% chance that at least one of these 10 animals will get adopted out in the next 3 months. Having watched this video, you should now be able to state the probability of at least one and calculate the probability of at least one in the context of a problem. If you're interested in animal adoption, you can go to the Barks website to donate, volunteer, or give a pet a forever home.